All right, so we're going to be doing the longest substring without repeating character question. So this is number 3 within LeetCode. This is a medium level question. And what's happening is, for this question in particular, what we're going to have to be using is the sliding window method, right? So you're given a string where it has a plethora of letters, right? For instance, example 1 has A, B, C, A, B, C, B, B. And you're trying to find the max length, right? The max length of the characters that do not repeat itself. So there's even an explanation here saying that the answer is ABC, right? With the length of 3. So we were going to be wanting to return 3 for this one, right? Value, because if you look A, B, and C, all these values are unique. However, for the 0, 1, 2, 3, for the third index, right, A repeats itself. So you want to just cut it off there, right? However, we do also want to check the rest of the string, so we need to make sure to accommodate for that as well. So how we're going to be doing this is basically what we're given. We're given a function, and we're given just an argument s, which is string, which I even wrote down here. S is going to equal this, and our output should be 3, right? All right, so a tool that we're going to use a data structure is a hash set, right? So I mentioned this in one of the earlier videos I did. So you have hash maps and hash sets. Hash sets in particular are really useful when making sure that that there shouldn't be duplicates of a certain value, because that's basically its whole premise, right? Is that you're able to add things within a hash set. However, once you add a particular value, whether let's say that's 1, right, the number 1, you can't add that again. There can be multiple instances of the one value. It will only appear once, right? So we're going to create a hash set. Then what we're going to do is called max length. So this is just going to be a variable which is going to hold max length, and this is what we're returning. So this is just a placeholder. And then what we're going to do is create 2 pointers, right? So for the sliding window effect, right? Don't get it. It's very similar to 2 pointers. It's sort of kind of like a variation of it. So, hence why we're creating these 2 pointers things. But you'll see its uniqueness in a couple of seconds. So we're going to make left equal to 0, and for right, instead of just setting a normal variable to the length of it, what we're going to do is actually incorporate a for loop. So for right in length of um, s, actually no, right in um, oh my goodness, in range. There you go, range of length s. There you go. So that's better. So you have left, which is at 0, and right, which is going to be iterating throughout here, right? Throughout the string that we have. And then what happens after this is, I will just write this comment here, is we're going to do hash set dot add. We're going to add s at index right? So what this line is doing is, okay, like, if it's normal and it doesn't repeat itself, right, just add that value into the hash set. However, we're going to do while s at index right is in our hash set, right? So what this is doing is like, okay, we're looping. Oh, this value is in our hash set, right? What do we need to do? Well, we're going to do hash set dot remove s at index left, right, and left plus equal to 1. So let's create some space. What's happening here is, let's say that within the string, right, that we hit this A. And once we hit this A, it's okay, well, we need to find out where the other A is, right, and remove it so we can continue going. So we're going to do hash set remove s at index left, which is 0, right? And luckily for us, once it does that, A will disappear, and then we would be left with this, right? So B, C, A, and now starting from B, right, in C and A, we have 3 unique values. And the same thing happens here. We go to the next value and it's B. Okay, well now we're going to hit this while loop because S at index right, B, is in hash set. So hash set to remove S at index left. Well, we just iterated left, so it would be back at B, right? We increase left by 1, so it would be here, right? And we would just remove it. And then it continues going on and so forth. So this is what this while loop's here for. Besides that, this hash set here is what usually will happen, which is just you're adding the values to the hash set. And then what we want to do is make sure we update our max length like this. And then we need to make sure to compare it to the max of max length, or right minus left plus 1, right? So this is updating our max length value. So if we have a value higher than the previous, then we make sure to replace it. If not, it just stays the same. Then we want to make sure we return this, right? Max length. And let's just take a look. We have our function argument, hash set, max length variable, your 2 pointers, starting at length s. Well, s index right is in hash set, right? Right in particular because that's where our for loop is pushing, right? Left doesn't really increment unless it's inside, unless we're removing. Okay, hash set dot add. Perfect. Let's do a print the function. Let's put in this string as the argument, just like in the LeetCode problem. And if we click run code, you get 3. Perfect. So to kind of demonstrate what's going on here visually, because that helps me learn, let's take a look at our problem. So let's say we're starting this code, right, at index 0 at A. Or actually, to make it even easier, because I have this example written up, let's pretend that S is this, right? Let's pretend S is this array. So we want to make sure, like, what's the longest length, right? And you can kind of see the answer here that it would be 3, because no matter where you look at, but 215, right? 215 is around, it's 3, right? From 1, 2, 3. And after that, you hit 1. And that's a problem because we already have 1 in the hash set. So what's going to happen? Well, let's create hash set here. And let's iterate through this together. So you create your set. This is our hash set right here, right? And you have left, which equals 0, right? And right, which is our for loop. And this is what's going to be continuing. So let's check the while loop, all right? Is s at index right in hash set? There's nothing in our hash set right now, right? So just hash set dot add s at index right. And of course we're going to iterate. So now this goes here, right? Left stays here because the only time left changes is in this while loop, right? And we got to make sure we add the value into our hash set. So we were just at what, 2? So hash set dot add 2, right? Then we do it again. We check for the while loop. Is s at index right? 1. Is 1 here? Nope, we only have 2, right? So we're going to add 1, right? And move right to another point, to the right of us. And then we do it again, right? So left is still at 0 because we have not encountered a value inside the hash set. Is s at index right in hash set? 5 is not, right? So in that instance, we're going to add, right? And move right to 1. Okay. Now this is where things get interesting, right? So we have 2, 1, 5. Now we're going to check, is while s at index right is in hash set, 1 is in fact in hash set, right? So this is a while loop. So this is going to continue doing something until the rules set into place are broken or whatever we have inside. And in this instance, is if it's s at index right is inside the hash set. So we are removing values from the hash set starting at s at index left, right? So left is at 0. So we're going to remove 2, right? So remove 2, right? And left is going to increment by 1, which is here. Okay, now look back. Well, s at index right is in hash set. It still is because s at index right is 1, and we're on 1 right now. So what's going to have to happen is we're going to remove 1, right? And move left here. Now we can continue going, right? So at this instance in time, then we would continue going on. But you already see we had to remove. Left is now here. So starting from left, we can kind of continue a new section, right? Which would start from here and from here, right? So what would it look like is that right would move, right? Here and here, because there's no values, no repeat values within the given hash set, because only 5's in it right now. So that's basically how it looked like for the list, right? And we already kind of went over how it would look like with the given example in LeetCode, which is with the string.